So in 4.3, you look at real zeros of polynomials, but before you can learn how to do that, you got to make sure you know how to do division of polynomials. Both long division and something called synthetic division. Synthetic division is a little easier than long division, okay? So to begin with this, we're going to do this long division, okay? And a lot of you have done this before. If you haven't done it before, you got to work on it a little bit. Okay, so we're going to take that and put the numerator under a division symbol, and then what we're going to do is put the x plus 9 like that. Okay, we're going to do long division like this. If you're an international student, there's a chance that nobody ever taught you how to divide this way. Okay, which can sometimes be a little bit of a learning curve on that. Okay, so one way to divide is like this. Now, you don't have to write this example down. I'm just going to do a real quick example of a long division problem, and the way we tend to do it on this side of the world. Not everybody learns how to do division this way. So the first thing that you always do is you divide. So 7 divided by 6 is 1, and then you record it. The second thing you always do is you multiply. So 1 times 6 is 6. The third thing you do is you subtract. So that's 1. And then the fourth thing you do is you bring down the next number. Okay, that's one loop through what we call the division algorithm. Okay, and we keep going through that loop over and over and over again. Now what we do is 11 divided by 6, which is 1. That takes care of your division step. 1 times 6 is 6. That's your multiplication. Then you subtract. That's 5. Then you bring down, and then one more time. 56 divided by 2 is 8. 8 times 6 is 48. Subtract, that's 4. Okay, so what you can say is two things. You can say 118 is the quotient. Okay, and then of course this is your remainder, so you would have a remainder of 4. Okay, if you're an international student, maybe you've never done that. Does that describe anybody out of curiosity? No. Okay, all right, there's always a few. That's okay. But you can do this kind of the way you learn too. So it doesn't really make that much difference. The other thing is, you probably learned on this, you can write this as 118 and 4/6, right? Now the reason I'm showing you that to you is because I don't think you would really understand the algebra unless you understood that. So what we end up doing is we approach this like this. The first step is division, and when you do division, that's what you're dividing. You're only looking at those two things only. So if we do that, we would have x squared divided by x to the first. What is that? That's x to the first, because you're subtracting exponents. That's the rule. So that gets recorded up there. That's just x. Okay, and that, again, that's your division step. Now you do your multiplication step, and the multiplication step, what you're really doing is x times x plus 9. So you're multiplying like a distributive property, so that's going to give positive x squared, and then plus 9x like that. Okay, then you're going to do the subtraction like that. So you divide, then you multiply. Okay, now you can subtract in your head if you want to. You can just say x squared minus x squared is really 0x squared. 4 minus 9 is really minus 5x. Okay, or you can do this. A lot of times I teach students to do this. When you subtract, subtraction is the same thing as changing signs and adding. Okay, so you just change the signs and add, then you got it. Okay, same thing. Okay, now if you move to the next thing here, we've done the subtraction, so now what do? You bring down the next number, minus 45 like that. Okay, now I'm going to erase that little part right there because that just cancels out. So typically if you're doing these problems, that thing's always going to cancel out. Okay, now what you need to do next is you need to go through and repeat the process. So what you're going to do now is you're going to do this division. You're going to do this divided by that. Most of the time you're going to be able to do that in your head without any problem. So what is negative 5x divided by x? It's negative 5. So you record it. Okay, and then you're back. You're on the second loop through the problem. So now you multiply. So now you're going to do negative 5 times x plus 9. So negative 5 times x is negative 5x. Negative 5 times 9 is negative 45. Then you can change the signs if you want to, but you don't have to. So I'm going to say, okay, that goes to positive, that goes to positive, and now we're done. See, that cancels. This cancels too, but we're really going to go ahead and write 0 like that. So we have a remainder of 0. Yes?
So for the negative 5, wouldn't you say positive 5, just so everything is positive 5x plus 45, and then subtract it?
Yeah. Well, I mean, so because what I've done is I've multiplied this times this, okay? And then really what you're doing is negative 5 subtract negative 5. Subtracting a negative is adding, right?
Yeah.
So that's the reason why I changed those signs. Okay, and then this is...
talking about up in the quotient.
Right, up here?
Yeah, instead of x minus 5, could it be x plus 5? Just so we wouldn't have to do the extra step on changing the symbol.
Are you talking about down there?
No, I'm saying, so you know, on the quotient you said negative 5, and then now negative 5 times x plus 9 equals up to negative 5x minus 45.
Right.
Instead of that, could we do plus 5?
Oh, you're kind of changing the signs as you go.
Yeah.
Yeah, that's fine.
Okay.
As long as you get it okay, that's fine. I mean, if you can process that, fine, I don't care. Okay, as long as you get it okay. All right, so this would be, the quotient would be x minus 5, and then the remainder would be 0. Okay, like that. Okay, and that's it. Now, one thing that I wanted to mention on this, and I'll do this just one time, is back when you were like in elementary school, how did you check the answer to a problem? You did 118 times 6, and then you added on the 4, right? You do the same thing on this problem, so let's do a check on this. Let's take that, x minus 5, and let's multiply it by that to verify that it's the right answer, and it should end up being what the divisor is, what that numerator is. So if you FOIL that, you're going to get x squared plus 9x minus 5x minus 45, so that's going to give x squared plus 4x minus 45, and notice that that matches up what it's supposed to match up with. Okay, so it's right. So you can tell you're right when you divide polynomials always, pretty much. Okay. Now you're not going to do a lot of long division. You're going to do a lot of synthetic division in this class. So let's go on and let's just do one more of these things. And I'll get you started through the first loop and then let you see if you can finish this one up. So again, let's start this like this. Put the numerator under the division symbol. Okay, then put the divisor, the denominator, out here. And let's just together go through one loop, and then I'll let you try to finish it up. Okay, if you're learning this for the first time, sometimes it's kind of helpful to write down the 4 steps of that division algorithm that we do. Okay, so step 1 is you're going to do division. And remember, all you're looking at is that right there. You don't look at anything else. You just look at those first 2 terms like that. You don't have to write anything on your paper. You can do this in your head if you want to. I would want you to be able to do that in your head. What is that? Negative 5x to the second, right? Okay, so you're going to record that that is negative 5x to the second. Okay, like that. So that's step 1. Step 1's complete. Okay, now you're going to multiply. And again, you can do this in your head. Now, I do find some students do better if they just do scratch work at the side. So if you do this, you're going to have positive 20 x to the third, and then minus 15x to the second. Okay, so that gets recorded down there. So that's plus 20x to the third, minus 15x to the second, like that. Okay, and that takes care of that. Okay? All right, now we subtract. Now you can do subtraction in your head. I could care less as long as you get it right, okay? But I typically show this a lot to students because it does help some students is change the signs and add. That's what subtraction is anyway, right? So what you would do then is this would cancel out, so don't put anything there. Negative 7 plus 15 is going to be 8x to the second. Now one more step. And then take it from there. Okay, so everybody just try from there and see what you get. Okay, you got 2 more loops from the problem. And see what you're going to do now in your second loop is you're now going to look at, when you do your division, you're dividing that by that. Okay, then just over and over again, 2 more loops. Divide, multiply, subtract, bring down the next number. and then just write out what the quotient remainder is, okay? And you'll have to do this a little bit in this class. You won't have to do it nearly as much as synthetic division. All right. Okay, so what you're doing is the next step is you're doing 8x squared divided by negative 4x, okay? That is negative 2x. Now, one thing I hope you guys are noticing, look at the answer. Aren't the exponents going down? They're descending, okay? Now you're going to do this thing, negative 2x, times this. Again, you can do that in your head. You just do the stuff on scratch paper if you need to. So that's plus 8x squared. This is minus 6x. Then you're ready to subtract, okay? Subtract in your head if you choose to, or change the signs and add. Take your pick on what you like doing better. Just get it right, okay? So this is going to be plus 4x like that. Then you bring down the next term like that. So if you got down to 4x plus 11, then you've done that loop right, okay? Then the next thing that you're going to do, basically, is you're going to divide this thing by this thing, okay? And when you do that, what do you get? Yeah, you got 4x over negative 4x, which is negative 1, like that, okay? Now just do the multiplication in your head. Negative 1 times negative 4x is positive 4x. You see how that matches? It always will. If it doesn't match that number, you've already messed up. Okay, then negative 1 times positive 3 is negative 3, like that. Then you want to change your signs, and then that would be 11 plus 3 would be 14. So how many people did get a remainder of 14? Okay, that's not too bad, okay, right? And if you're wondering this changing the sign, see, all you're doing is 11 minus negative 3. You're subtracting negative 3, and you know that's adding. That's why you're doing that, okay? So what that would mean, the answer, the quotient, is negative 5x the second minus 2x minus 1, and then you have a remainder of 14 like that, okay? That's the idea. All right, is there any question on that? Okay, now we're going to do synthetic division next, and then we'll do a break after we're done with that. Synthetic division, if you catch on to it, you'll be able to do the problems very quickly and very efficiently if you don't make any arithmetic mistakes, okay? All right, so synthetic division. Now this only works for a certain thing. Did everybody get this written down? Okay? Okay, all right. Okay, synthetic division. The thing on synthetic division is it only works on this kind of a problem. So you have like some polynomial. I'm not going to put a polynomial there. So you're dividing by x plus 2 or something like that. Okay, you couldn't be dividing by x squared plus 2. It doesn't work. Or you could have divide by x minus something. Okay, and that can be any number. It doesn't have to be a whole number. It can be like that. So the structure is synthetically you can divide when you're dividing by x plus a number or x minus a number. That's the structure. Nothing else though. Okay? No, same thing on that. You can't have anything in front of that either. It's just x plus something, x minus something. Okay? It can be worked out in a certain way that way, but we're only going to look at the ones where it's x plus something or x minus something. Okay? All right? Okay, so let's go through how we do this then. So if you look at number 3, this has the structure. You're dividing by x plus 5. Okay? So it turns out, first thing that you want to do is you just want to do a division bar. Okay? And what you're going to do is you're going to write down the coefficients of each power of x. Those things right there. And you got to make sure that you don't have anything missing on this. So what you kind of have is you have like a place for x to the 5th. You don't necessarily need to write down these powers. I'm only just kind of telling you the structure on this is like this. You have to have a placeholder for everything. So if you have an x to the 5th, you want to make sure that you have something there for everything. So you just go like this. 1, and then 7, then 12, then 12 again, 13, and 16. So that's the setup, like that. You don't worry about the x's, just worry about the numbers, okay? Now, what you do on this is you don't worry about the x plus 5. Think of it this way. If you had the equation x plus 5 equals 0, what's the answer? Negative 5. So you have to use a negative 5 there, okay? All right? Okay, so now watch how I do the synthetic division here. All right, now what you're going to do is draw a big bar like that. And you're going to run through it like this. The steps are very simple. Step 1 is bring down the first number. Okay? Step 2 is to multiply these two numbers. Negative 5 times 1 is negative 5. So you put that there. Okay? Step 3 is add the column. So 7 added to negative 5 is 2. Now you're going to keep doing this over and over and over again. So now what I do, 2 times negative 5 is negative 10. Add the column. 12 added to negative 10 is 2. Now what? Multiply. Negative 5 times 2 is negative 10. Okay? Add the column. 12 plus negative 10 is 2. Multiply. 2 times negative 5 is negative 10. Don't put it there, though. Okay? Put it here. 2 times negative 5 is negative 10. Add the column, that's 3. 3 times negative 5 is negative 15. That's 1. Did you guys catch what I was doing? Okay. Sometimes students don't catch it the first time, but the idea is, phone, please, thank you. All right. So, again, bring down the number, multiply, record, add, always like that. So here's basically what happens. That's the remainder. Okay, if you did this problem by long division, you'd still be working on it. You might be on the second round through this. So that's the remainder right there. And these powers always go down 1. So this is really, this started off as an x to the 5th, so that's going to be x to the 4th, x to the 3rd, x to the 2nd, x, and a constant. So the answer is 1 x to the 4th plus 2x to the 3rd, and so forth, plus 2x to the 2nd, plus 2x, and then plus 3. That's it. Was that easier? So some mathematician figured out it doesn't matter that you put all those x's and stuff in there. All that matters is the numbers.
Why is it C?
C is a constant. Okay, it means there's no variable with it. So you'll end up, the number right before the remainder is just a constant. See, I just put 3 there. Okay, the variables go down. Okay? How'd that look? Yeah, okay. All right, let's try another one here, then I'll run through. I'm going to set you up on this one, and I'll let you try to crunch this one out. Okay, so with this one, start by doing division bar. The highest power is 3, so you want to make sure that you have a column for everything. X to the 3rd, x to the 2nd, x to the 1st, constant, like that. And when you're doing these problems, you're not required to put that stuff on top. I'm using that more as for teaching. So what's the number in front of x to the 3rd? 1. Is there an x to the 2nd in your problem?
0.
No, so you've got to put a 0 there. It has to be a placeholder. Is there an x to the 1st in the numerator? No. But there is a constant like that. Okay? Next thing you do is always put the opposite number. Try to think of it this way. That'll help you understand what we're going to do later. What's the solution of this equation? X equals 1, right? 1 minus 1 is 0. Okay, so we do that. Okay? Now, I'll take you through 2 steps and you finish the rest and see if you can write the answer to everything. You always start by bringing down the first number. Okay? Then what do? 1 times 1 is 1. Then what do? Add the column. Okay? Try from there. Finish it. You guys see what I'm doing?
Wouldn't it be negative 1? Because 0 minus
Nope.
1?
Nope. The thing on this is that's an x minus 1. So the structure is you're really dividing by minus a number. Like that. Okay? So it's going to be like, that's already a number. Or think of it this way. This is what I was showing. You're going to use the opposite of that number because you're looking at a 0. X minus 1 equals 0. The answer to that question is 1, isn't it? Right? If you had x plus 1 equals 0, what's the answer to that equation? Then you use negative 1. Okay? Because the structure of it, you're always dividing by x minus c. Okay? That's got the structure, so just use the 1. That's the idea. Okay?
Okay.
Okay, well, let's see if we got the rest of this here. So 1 times 1 is going to be 1. Add the column, you got 1. 1 times 1 is 1. Add the column, -2. Okay, so what is the meaning of that -2? That's your remainder. Okay, so that is your remainder, like that. Okay, now the powers go down 1. So this is going to go x to the second, x to the first, constant term. That means it doesn't have an x. So the answer to the problem is 1x to the second plus 1x plus 1 with a remainder of -2 like that. Okay? Does that make sense?
Yeah.
Okay, once you catch on to it, you won't have much trouble with it. You're going to do synthetic division a bunch, so you'll get to where you can go through it with ease. Okay? Let's do one more problem, then I'll give you a well-deserved break. Okay. All right, so this one, the highest power is x to the fourth. You need to have an x to the third, an x to the second, an x to the first, and a constant term. You need to make sure that you have a placeholder for every single thing. All right, so the coefficient of the x to the fourth is 3. You do not have an x to the third, so what do?
0.
A 0. Then you have a 4 for the x to the second. You do not have an x to the first, put a 0, but you do have a constant term. All right, now be sure that you get this under control now. What do you use? 1/2 or -1/2? 1/2, okay? The solution of that equation is +1/2. Again, so you're going to put a 1/2 like this. Okay, now we got a fraction. Please don't panic. You can do it. You really can, okay? And halves are real easy to work with. So what you do is you just go straight down like this. Bring down the first number, okay? Go to the side if you need to. And if you were to do 3 times 1/2, you would get 3/2. And you can use decimals if you want to. I prefer that you just use fractions, though, so let's do that. 3/2. And the reason you don't want to use decimals is they repeat sometimes, and you have to round them, so you lose accuracy. Now add the column, which of course is 3/2. Okay? Now multiply these numbers. If you can't do it in your head, write it down on scratch paper and do it. So that is 3/4. Like that. Okay. Now you're going to do 4 plus 3/4. The best way to do that to me is just it's 4 3/4, right? Okay. Now you can change it to a mixed number or an improper fraction, which you're going to have to ultimately anyway. So 4 times 4 is 16. 16 plus 3 is 19. So it's 19/4. Okay. Little fraction things you got to make sure you know how to do. Okay, did you guys follow that? Okay, I see students who haven't done that in years in this class. Okay, add the, hold on, what am I doing? I forget, that needs to go here. Sorry, I do that a lot to get distracted in what I'm doing. Okay, so we got that. Now we're going to multiply. Okay, so when we multiply, we're going to do 1/2 times 19/4. What's that? That's 19/8, right? Okay. Add the column. That's going to be 19/8, like that. So it's nice if you have a 0. Multiply, so you're going to have 1/2 times 19/8, which is 19/16, and then that goes there. Okay. Now you got to add these numbers. Well, let's do that to the side. You're going to do -1 plus 19/16. How do you add that? You got to get a common denominator, right? Which is what? 16. Okay, yeah, so you can change this to -16/16 plus 19/16. So that's going to be -16 plus 9 is going to be 3. So you would have a remainder of 3/16. Okay, it's the same process, but you do have to deal with the fraction arithmetic. And you can't get rid of the fractions on this. You just have to deal with it. You have no choice. So your remainder is 3/16. Okay, and then the 3, what power is the 3 going to be in this result? Yeah, that's going to be third power. So 3x to the third, this is going to be plus 3/2 x to the second, plus 19/4 x to the first, plus the constant term, then that would be your answer, like that. Okay, the exponent always goes down 1 on these problems because you're dividing by x to the first. So if x to the fourth is the highest power, x to the first is the highest in your answer. Now that's a little harder, but it's just got arithmetic involved in it, so you got to be pretty solid with that. What I'm going to do next here is what we call the remainder theorem. It's good to have your calculator for this, so if you got a calculator, you might want to get that out, and I'll use it to demonstrate a few things, and you can do it along with me if you want. So the main thing when we're dealing with the remainder theorem is I'm going to just kind of explain this by an example, and that's the best thing to go through before we go through the technical talk of this. So the first thing that I want to do on this is we're going to put this in our graphing calculator. So if you want to do this with me, you can. So you're going to press your y equals button and just put in the function. So we're going to put in negative 8x to the third plus 16 x to the second, and then minus 8x. And we may have to adjust the window a little bit on here. So you want to do that. Get that put in. And if you want to do this in a standard window, you can always do this to get there real fast. You can go zoom and then go down to number 6. And then that'll put you in a standard window. And I'll see how this looks. This should be a cubic function. Okay, now that is a cubic function. It's probably I'm probably gonna have you change this window to one other thing so you'll see this a little bit better. So let me put the window on here, and if you're doing this with me, change your window like this. Let's go negative 2 to 2 by a scale of 1. Okay, put that in. That'll just zoom on it a little bit like this, and that'll help you see something a little bit better. Okay, so that looks like a cubic function. It's got the endpoint behavior we would expect. So what I want you to do, I'll leave the calculator up here, is just go through and draw a coordinate system. And we're going to go to 2, and we're going to make a very rough sketch of this. It doesn't have to be that great. And the main things that I want you to have on your function are these key points. It looks like it goes through 0. Looks like it has an intercept of that, and then it kind of swings through like this and does something kind of like this. Okay, that's all I want. It's just a real rough sketch like that. Okay. Now, what we're going to do next, I'm going to leave the graph up there, is we're going to do synthetic division. This is part of the reason why we went through synthetic division. When you're learning the remainder theorem, want to look at this. So what I want you to do is we're going to go ahead and get this set up for synthetic division. So I'm going to slide this over the side here for a minute, and let's get this put in. So we're going to draw our division bar, and we're going to have an x to the third term, x to the second, x, and a constant. You want to make sure everything's there. So you're going to have negative 8, then 16, negative 8, and you do not have a constant there. You don't just have a number, so you have to put a 0 there. Okay? Now, what you're going to do next is you're going to we're going to be looking at a function value here. So whatever I'm looking for is going to go there. You don't change the sign or anything. When you're doing this, you just put that there. And then I'll try to use this to show you what the remainder theorem shows. I want to do this before I even tell you what the remainder theorem is. Okay? So what we're going to go through and do is we're going to synthetically divide this like we learned. Okay, so we're taking the polynomial divided by 1/2. So you're going to bring down the first number. And then this one should be pretty easy. So you do 1/2 of negative 8 is what? Negative 4. Okay, add the column. 16 added to negative 4 is 12. 1/2 times 12 is what? 6. Add the column. Negative 8 plus 6 is negative 2. 1/2 times negative 2 is negative 1. Then add the column right there. So that is the remainder. So I want to show you this, and then I want to show you one other thing then. Okay, before I go to the graphing calculator. All right, so that's a remainder. Now, I want to do one additional thing with this problem for a minute. Just one more thing. Then we'll kind of talk about what this remainder theorem is then. Okay, so let's do this also. I want you to work out f of 1/2 the way that you're used to working it out. The way you learned how to do that is just take the function, and everywhere you see an x, plug in a 1/2. We're going to go ahead and just crunch this out. see what happens and see if we can make a connection here. So you're taking the function that I gave you, and now just plug in 1/2 everywhere you see the x like that, okay? And don't be intimidated by the fractions. Trust me, they'll work their way out of the problem, okay? All right, so if you do this, now if you're going to work out 1/2 to the 3rd power, you're going to multiply it out 3 times. So that's going to be times 1/8. And see, those 8s are going to cancel out, okay? If you're going to do 1/2 to the 2nd power, that's 1/2 times 1/2. So that's going to be 1/4. And then that's 1/2 there, so then you're going to have -8 times 1/2 like that. Now what we're going to do is just kind of cancel out the fractions. So that's going to cross out, leaving you -1. 16 over 4 is going to give +4. And then 8 over 2 is going to give -4 like that. 4's cross out, you get -1. Look at that. That's the connection I want to help you make, is when you did f of 1/2 the way that you've learned how to do that, you really have the same thing as doing synthetic division and getting a remainder. They end up being exactly the same thing. Now let me ask you a question. If you had two ways to do this problem, would you rather deal with all the fractions and do this, or would you rather just do synthetic division, out of curiosity? Synthetic division is actually a little simpler. When you get right down to it, it's faster. So if you're evaluating a function, you can do that. Now, the thing I want to show you on the graphing calculator now is this. Okay, so if you were to do this, if you type this trace button and you put in 1/2, so you just go trace and then 1 divided by 2, look what comes out, -1. That's what we found. Is it turns out when you do synthetic division on a polynomial, you can find the value of the function. So that's what that is when x is equal to 1/2, you end up getting this point. So you might also write a little note to yourself that that's 1/2 -1. That's what it is. That's what the remainder theorem is. So it means if you're evaluating a function, a polynomial function, what you can do is synthetic division, and whatever the remainder is the value of the function. Does that make any sense? Okay, that's the remainder theorem. Okay, it's actually not that hard of a thing to do, but you want to make sure that you catch on to what we're doing with that then. Okay, so let's just do this one. Let's kind of do this backwards. And if you want to find f of -2 using the remainder theorem, you're not going to plug the f of -2 in there. You're going to do this. So we're going to do synthetic division now. And we're going to divide by that -2. Don't change that sign, because we're not looking at a factor. We're looking at a specific number. And then just put your numbers in. So you'd have 1, -4, 3, and 5, like that. And all we got to do is figure out the remainder. And like I said, once you get to the hang of doing synthetic division, you can do this real fast. So bring down the first number, multiply. -2 times 1 is -2. Add the column, that's -6. Multiply, that's +12. Add the column, that's 15. Multiply -2 times 15 is -30. So the remainder is -25. So that means the remainder is -25. So what's the answer to f of -2? It's also -25. That's what the remainder theorem says. Okay, that right there is what f of -2 is equal to. Okay. Now, I'm going to just do a real quick graph on this, and you can do this with me if you want. It's kind of a nice tool. When you're doing your homework and stuff, you want to do it by hand, but you want to learn to use your calculator to help you understand this stuff. So I'm going to just put in the function x to the 3rd minus 4x to the 2nd, and then plus 3x and plus 5. Okay, and then we're going to, let's just do this go back to a standard window. So I'm going to go zoom 6, and this is going to come out. And really all you got to do to verify your answer to this problem is this. If you type trace and plug in the -2, a -25 comes out. That's it. That's what the remainder theorem basically is. Does that make sense? Okay, so it is giving you a function value then. All right, so let's just make a real rough graph. It doesn't have to be all that great. All I really want you to do on this graph is kind of is kind of do this just for your own notes here. So you've got when x is -2, you have a point -2, -25. Okay, and then the rest of it just kind of wing it through there like this, just so that you have kind of a record. You can kind of see what you got there, kind of like that. Okay, that's a very rough graph. But the important thing on this is this, that you understand that. Okay? Okay, so that's what we mean by the remainder theorem. Any questions about that? Okay, so you're evaluating a function. Don't plug it into the function, just do synthetic division. That's what we mean. Okay? All right, now we're going to look at what we call the factor theorem. Then we'll kind of look at a different way to find zeros of polynomials. Okay? So I'm just going to do this problem, then I'll kind of explain what the terminology up here says. So what we're going to do on this is the question is this a factor of this polynomial? So that's what we're going to look at is yes or no, is that a factor of it? So the way we're going to do this using what's called the factor theorem is you're going to do synthetic division. Okay, and then something happens that will tell us if that's a factor or not. All right, so first of all, put the numbers in the polynomial under the division symbol. So you've got 1x to the third, -10x to the second, plus 27x, and then minus 18 like that. Okay? Now, when you're doing a factor, make sure you don't get this messed up. What's the answer to the equation x minus 1 equals 0? It's 1. So you put a positive 1 there. So that's important that you always get that way. Now let's go through. Now let's divide this out. So that will go bring down the 1, multiply, that's 1. Add, that's -9. Multiply, that's -9. Add the column, that's 18. 1 times 18 is 18. So we have a remainder of 0. Okay? Now we'll look at this graphically here in just a minute, but if the remainder is 0, that means the answer is yes, it is a factor. Okay? So what would happen on this problem, I want to show you, have you write this down, then we'll look at a problem here. So what we just found is this. And write down the function too, because I want you to have this on your notes. Actually, what we have is x minus 1 is a factor, and this thing right here gives you what? The power went down 1, so that's 1x to the second minus 9x plus 18. So that's another factor. So you have x squared minus 9x plus 18. And that thing may even factor further. Okay? So what happens is, if you multiplied this out, I'm not going to take the time to do that, but if you multiplied that out, you would get the polynomial. So since that's a remainder of 0, that means that this is a factor and that's a factor. If that remainder was not 0, it's not a factor anymore. Okay? And what will happen on this, and I'm not going to have you draw a graph on this, but I just want to kind of show you what happens on this, is if you put this in, if you've got x to the third, and then minus 10x to the second, and let's see, plus 27x, and minus 18, there's something kind of special that happens on the graph when x is 1. All I want you to do is see this. Okay? What's happening when x is equal to 1 on my graphing calculator? What kind of point is that? It's an x-intercept. Okay? So that is a 0 like that. And see, like if you went to your, did a trace on this, if you trace at 1, that is the y value, that's the 0. That is actually the remainder. Okay? So that means that that is going to be a factor. It also means that x equals 1 is a 0 of that polynomial. Does that make any sense?
Why can't it be a factor if there is a remainder?
Oh,
if all you have to do is add the remainder.
No. Well, what would happen if you had a remainder of 1 based on the previous theorem we had, okay, then that would end up meaning that the function value would not have a y value of 0. When you have a y value of 0, which is the remainder, that means you're on the x-axis. And you know that. You know x-intercepts have y values of 0. Right. So that's why. If you had a remainder of 4, you wouldn't be on the x-axis anymore. That would be your y value. Because the previous problem we did showed that that remainder is really the function's value or the y value. Does that make sense? Okay, very good. And good question, okay, because that's what that is saying. Okay, so let's do this one. Let's just set this up, and you can do this yourself. If I want you to do the factor theorem, okay, just go ahead and get it put together. So you have 1x the third, negative 10x the second, 14, and 80. And then what are you going to use for x plus 5? 5 or negative 5? Okay, go ahead and finish it up and just tell me yes or no. If you caught on to your synthetic division, you'll be done in less than 20 seconds. Okay, if you got pretty good mental arithmetic skills. You can use your calculator a little bit too, but I think the stuff on this problem should work out pretty well then. And then while you guys are doing that, I'm going to go ahead and put this in the calculator and just show you one more illustration of that. So I already know the answer based on the graph. What did you get?
No.
No. Did you get a remainder yet?
Yes.
What did you get? Yeah. You didn't even bother. I would have done the same thing because it was too big. But I answered the question.
I got negative 365.
Yeah, that's like way down there, I think. Yeah. All right, so let's run through it, and then I'll kind of talk about the graph a little bit here. So that's 1, negative 5, negative 15, 75. So that would be 89. And then see, here's where I'm kind of like, and I think what you're saying is you kind of saw that it wasn't going to be, which is fine. I don't have any problem with that. That's good. I saw the same thing. So if we went ahead and finished up the details, then you have negative 5 times 89 is going to give negative 445. And then if we add 80 to that, you get into some pretty big numbers on this, so you'll get negative 365. Okay? So that means the answer is no, because the remainder is not 0. That's it. Okay? So it's arithmetic. And if you look at the graphing calculator on here, like for instance, I just put that in there in a standard window, but if you typed trace negative 5, look what happens. You get negative 365. Okay? So that means that point is way down there. It's not an x-intercept, so it can't be a 0. That's the idea. Okay, does that make any sense? Okay? All right, so you just got to look at that remainder. That's what the factor theorem is saying. Okay, this next problem is just an application of this, just something a little different, and then we'll finish up with doing a few things with this stuff. Okay, so what you're doing on this is you're finding a value of k. Your job is to find a value that makes this a factor, that x plus 5 a factor. So the way to solve this problem is synthetic division. So you're going to start by putting in the coefficients. You have x to the third, you have that. You have an x to the second, so you put the 8. You have an x to the first, you put the 14. And then you have a k, which is a constant, okay? Now synthetically, what do I use? 5 or negative 5? Negative 5, okay? Now let's just synthetically divide, and remember your job is to tell me what value of k would cause this to be a factor. Okay, so we just start doing the synthetic division. So bring down the 1, multiply, that's negative 5, add the column, that's 3, negative 5 times 3 is negative 15, that adds to negative 1, this gives 5, and then what do you have at that last step? 5 plus k, good. Okay, they're unlike terms, you just write it that way. Now, if you want this to be a factor, what does 5 plus k have to be equal to? Factor theorem said the remainder had to be 0, right? Okay, so what does k have to be? Negative 5. Okay, if k was negative 5, you would end up with a remainder of 0, right? Okay, does that make sense? Okay. So you've created a polynomial that would have x plus 5 as a factor like that, okay? That's the idea. Does that make sense? Yeah. Okay. Okay, now let's see. Now we're going to do a little factoring on this next one here. We're going to use a lot of synthetic division to do this. So it says you're going to factor this into linear factors. Linear factors mean like x plus or minus c, like x plus 2, x minus 2. That's linear, okay? You know, mx plus b type of form. So what we're going to do on this is k is a 0, and I'm giving you the 0 as 6. Okay, so synthetic division. Like I said, all this stuff is going to be tons of synthetic division. So go ahead and get everything set up. You don't have to put these x's and stuff up here. I'm just emphasizing that you want to make sure that you have a place value for every power of x. Then put the 6 there, and then we're going to factor this, okay? Now, just go ahead and do the synthetic division. So that's going to be, bring down the 1. 1 times 6 is going to be 6. Add the column, that's 4. Multiply, that's 24. Add the column, that's negative 12. 6 times negative 12 is negative 72. So we got a remainder of 0. The remainder is equal to 0. Now we use synthetic division to factor. Okay, like if you took intermediate algebra, you probably never learned how to factor. Well, you may have, because you may have learned factor by grouping. You could actually probably factor this polynomial by factor by grouping. But what this means is this. Again, this is x to the second. This is x to the first. That's a constant term. So what you're going to do is you're going to write this in a factored form. So the second factor is going to be x to the second. This is going to be plus 4x minus 12, okay, like we've been talking about. Now this thing right here, the structure is always x minus something. It's always like that. That's the structure of the factor, so you just put in a 6 like that. So that is actually how that polynomial factors. Okay, that is the factoring of that polynomial. Now, I think on this you could actually factor in one more step. I think. Does it look like that factors? Can you think of numbers that multiply to give 12 that add up to 4? 6 and 2. Okay, so I think that goes one step further. So we're going to go ahead and do that. So you're going to bring this down. And then the thing that I highlighted, you're going to factor that. So that's x and x. The two numbers on that are going to be 6 and 2. And you said, what, plus 6, minus 2 like that. So that is how you factor that polynomial. So synthetic division can be used to factor, and factoring ultimately leads to the zeros, okay? So let me see if you can tell me this. What are the zeros of this polynomial based on the factor? There's 3 of them. What are they?
6, negative 6, and 2.
6, negative 6, and 2, exactly. Those are going to be the 3 places where that graph crosses the x-axis, okay, like that. Okay, that's pretty cool, don't you think? Yeah, it's not bad. It's not bad. Yeah, okay. Okay, I'll let you guys try this number 12. Let's go ahead and just kind of get this set up together. So we have 2, negative 3, negative 5, 6, and just put the k equals 1 there. Now your job is going to be factor it. You may or may not have 3 parentheses, but just see if you can kind of do what I just did there, okay? Can I help you with something? Okay, are you done with this problem?
Yeah, stop waiting for you to hands up.
Do you need to get this copy down?
Yeah.
Okay. 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 So just make sure you got your synthetic division done first. So that's 2. 1 times 2 is 2. That's negative 1. Multiply, that's negative 1. Add, that's negative 6. And you got a remainder of 0. By the way, you have to have a remainder of 0, because if you don't, it's not even a factor. The problem's designed to be that way. So now here's what you do. That thing is going to be x minus whatever that is. Now, what if that was a negative 1? Then you would say x minus negative 1, so it'd be x plus 1, right? Okay. Now you put this in. This is going to be 2x to the second minus 1x minus 6 like that, okay? Now, the next question is, does this factor? It might. I'm going to go ahead and try and see if it does. So we'll look at that second parenthesis, and we'll see if we can go any further with that then. Okay, so if I do this, let's see, this is x minus 1. First term would be 2x and x. This would be probably 3 and 2. And I bet if you did it like this,
Plus 3 and
then you would have a 3x and a 4x to get a negative x. Does that work? Indeed it does. Okay, so it looks like you would have a plus 3 there and a minus 2 there. So you've got to factor that further if it factors. So that would be your factors like that. Okay, what are the zeros on this problem?
1, negative 3, and 2.
1, negative 3 halves, and 2. So like that. So once you get everything factored, you can. And some of you may need to work on this kind of factor where you have more of a trial and error type of thing. So that would be how you get that factor together then. Okay, so you can use synthetic division to factor. Okay, and that ultimately leads you to some things you can do with the graph. Okay, so I want to finish up this section with a couple more things. So we're going to find all of the rational zeros, and we're going to do this by factoring. Okay, now what we're going to do with this one is we're going to kind of go through these steps right here. The first thing we're going to do is we're going to write down all the factors of the constant term. The constant term is this thing right here. So the thing on that is it's either 1 and 3 are the only factors, right? Okay, but they could be positive or negative. So we just do that, okay? You probably want to write this like plus minus 1, plus minus 3. Now it says, by trial and error, synthetically divide by one of these factors until you get a remainder of 0. Okay, now this is the modern world. Now, back when I was in college algebra, way back when in the distant past, we had to just do it over and over again until we found one. Okay, here's what you do in the modern world. You get your calculator out. Okay, seriously. I don't mind you doing this. Now, the way, like when we get to tests and stuff, oftentimes I'll give you that value just to see if you know how to finish the problem. So, you could go ahead and trial and error all 4 of those until you found one that had a remainder of 0, or you can save time by doing this. Take your pick. So I'm going to put in the function x to the third minus 3x to the second minus x plus 3, graph it in the standard window. Okay, and you don't need to do this if you want to. You can just watch this if you want to. Standard window. Okay, this will tell you a 0. It might even tell you every 0 in this problem. Do you see any zeros based on that graph? Here they are. They are negative 1, okay? What else? 1 and 3, right? Those are the places where you cross, okay? And if you aren't sure, you can do this. Trace, negative 1, okay? 0, okay, like that. That is a 0. Now I'm going to put the calculator away. It's almost like it just did the answer for you. Now, and sometimes it will, but sometimes it won't give everything. So let's go ahead now, since we found a 0, and let's do this synthetic division then. Okay, like this. Okay, yeah.
So we found 3 numbers.
And you can take your pick on which one you want. Doesn't make a bit of difference, okay? Yeah, they all work the same way. Okay, if you pick one, it'll generate the other 2. Okay, so let's do synthetic division. So bring down the 1, multiply, that's negative 1, that's negative 4. I don't know why I put an x there. I should have put a negative 1 there. Okay, multiply, that's negative 4. Add the column. What in the world am I doing here? Positive. How did I catch my mistake? I knew the remainder was going to be 0. Okay, so it helps if you understand, the little things that you're looking for in the problems, okay? All right? All right, so let's finish that up then. So that's supposed to be a negative 1 there, so that's 3, that's negative 3, so that's 0, okay? So now what you have then is this will factor. So this basically is x squared minus 4x plus 3. And that is a factor, and so is this. Now see, this one, that 0 we found, we would say x plus 1. because it's always minus that number, like that, okay? Now you want to factor this further. So this is x plus 1, like this. This thing right here will factor. You'll have x and x. You'll have 3 and 1 to give 3, and then 2 minus signs, minus and minus, like that. So you factored it, okay? Now, I would hope that you could tell me the 3 zeros in your head. What are they?
-1, 1, 3.
That's it. There's your answer to your problem right there. And the graphing calculator did that. Students always say, well, why can't I use my calculator? Well, you can use your calculator to assist you in learning the principles and checking and everything, but you're going to find situations where those other 2 zeros, you're not going to be able to get them with your calculator. There's no way to get them. So it's a good thing to know how to do this, but it's also good to know how to do this on your calculator, okay, because it does help and speed it up. So that would be what I would recommend, is just find that first 0, not by trial and error. Just get your calculator out, okay? What do you think? Okay, anything that saves you time, okay? Because, I mean, you could end up with a possibility. What if this number right here was 240 instead of 3? Yeah, think all the factors you would have. That'd be a nightmare, wouldn't it? Use your calculator to start you. Yeah.
Why does sign changes?
What sign are you? Oh, this right here?
Oh, those would be equal to.
Yeah, the structure is x minus that number, okay? Yeah, and that -1's a 0, so you have to have that written as x plus 1 to generate that then. Okay, so let's do this last problem here, and do this, just one more illustration of this. Okay, so we're going to run through this like this. We're going to set up the synthetic division, and then we're going to set this up together, and then I'll let you finish it, and then I think that's probably where we'll stop today. So we're going to do this. Now, what you want to do in this case is you want to just identify all of the factors of 14. So what do you have? You have 1 and 14. You have 2 and 7. You also have, they could also be negative or they could be positive. Those are the possible zeros on this problem. If they exist, on this problem at least, that's what you're going to have. All right, so I'll put this in, and then I'll let you see if you can finish it up. So x to the third minus 8x to the second, and then plus 5x, and then plus 14. Okay? Going to do that in the standard window? Okay? I won't say anything. Now you're on your own. I won't even say how to finish it. See if you can finish it. How many zeros do you see? 3. Pick one. Pick one and do the synthetic division and use that to find the other 2. I mean, the calculator's telling you what the 3 zeros are. They're staring you right in the face, right? So finish. Pick a 0 and divide and see if you can finish it up. Okay? And it doesn't matter which 0 you pick, seriously. Okay? You can pick any one you want to. Up on this today then. Okay, I picked 2. Again, it doesn't matter what you pick. You could have chose -1, 2, or 7. Okay, so I'm going to bring that down. 1 times 2 is 2. That's -6, -12, -7, and -14. So you end up with that. So what this means is this is really the factor x minus 2. And then this thing goes like this. I'll start with 1 parenthesis, and then you'll end up having this is x squared minus 6x minus 7. If you didn't do it this way, it doesn't matter, okay? You'll still get it. Now, when I factor this trinomial, I'm going to have x and x, 7 and 1, with a minus and a plus like that. So, what are the zeros?
2, 7, and 1.
Just like the calculator told you, right? But the calculator helped you get started. That's what I want you to see. So that way you don't have to waste your time with trial and error. Okay. All right, so I'll finish up today, and then we'll bring those packets to class next time.